Hello everyone and welcome back to Learn It Up. Today in this video we'll be talking about scalar product. Let me just write that down. Scalar product. Okay, so what is scalar product? So imagine if we have to multiply two vectors like 5 and 4, 5 and 4. We can basically just multiply them by using 5 into 4 is equal to 20. But if we have to multiply vectors, it is a completely different case. Like if you have been given a vector f is equals to 5 meter per second and another vector q is equals to 3 meter per second. Okay, so now remember they are vectors, so they need to have a direction. So they are going, the f is going at 60 degree from x and q is going at 30 degree from x. So what is a scalar product? For a scalar product we can write it as f vector and dot. The scalar product is represented by dot because it is also known as dot product. So f into q will be magnitude of f magnitude of q multiplied into cos theta, where theta is the angle between the vectors. So theta is the angle between the vectors. So now if we solve this, it will be, what was f? It was 5 and q was 3, and now we have to find the angle. So f was 60 degree from the x-axis and q was 30 degree from the x-axis. So the angle between them would be 30 degrees. So we have to multiply that by cos 30. So this expression here, will be the result of f vector multiplied by q vector in a dot product. So now you may ask why we use a dot product. We use dot products because it helps us in vector multiplication. For example, you have to find the work done. So you must have read that work done is force into displacement. But if we write this in vector form, which is very important, if we write this in vector form, it will be f vector dot s vector. Just we have studied that this will be the magnitude of f into magnitude of s into cos theta, which is the angle between them. So this will be the expression of work done in vector form. And this is the reason why you must have learned that if we lift up a object and carry it in the x direction, that there is no work done here, because we are applying force directly upwards in the y direction and our displacement is in directly x direction, x axis. So the angle between these vectors is 90 degree, and let's mark the force upward as f and the displacement as s. So the angle is 90 degree, so the dot product will be f into s into cos 90. What is cos 90? It's 0. So the work done comes out as 0. Hence it has been proved that if we carry an object and move perpendicularly to it, we are not doing any work. So this was the basic of unit vector. And the second way in which a scalar product is used is by using unit vectors. Scalar product with unit vectors. So let's say, for example, you have been given a unit vector, a vector in the form of unit vector. Let's say it's q, so it will be in the form of a I cap plus b j cap. And let's say you have another vector p, let's just say, and it is x I cap plus y j cap. So now if we dot product these, which will be q dot p vector, this will be equal to magnitude of q multiplied by magnitude of p into cos theta if we used the above form, but this has been given in unit vector form. So this expression will not be used here. What will be used here is a completely different technique. So we can write this as ai cap plus bj cap dot xi cap plus yj cap. Now if we dot multiply this, it will be axi cap into I cap, and we'll just take only this part as an example. So what is I cap? You may remember I cap is the x direction, and this I cap is also the x direction. So the angle between these two vectors, because this I cap is a unit vector and it is a vector, so it will have direction. So the angle between them is 0 degree. So if we cross multiply, it will be I cap into I cap cos 0, which will come out as I cap. So I cap squared, because cos 0 is just 1. So the value of this will be ax I squared, but I cap is a unit vector, it has a magnitude of 1. So this will just come out as ax. This is how you multiply the same unit vectors like I cap and I cap, but if you multiply different vectors like I cap multiplied by yj cap, this will come out as 0. Let's talk about that. So what will this be? Ay into I into j. So I is the x direction while j is the y axis. So the angle between them is 90 degree. So what will this be? Ay cos, this will be ij cos 90. And what is cos 90? It's 0. So the vector will become 0 and the whole expression will come out as 0. So if we dot product different unit vectors, different axis unit vectors, it will have no consequences in the multiplication of other vector. So let's take an example. The force is 5 I cap plus 2 j cap, and the displacement is, let's say, 3 I cap plus 4 j cap. So we have to find the work done. So we can either find the magnitude of these and multiply them, but it will be easier if we do it in the unit vector dot product. So work done is force dot displacement. So this will be, what is the force? 5i plus 2j dot 3i plus 4j. So if we follow the rules that I just told you, we will multiply only the same capped vectors and just ignore them and only use the magnitude, because as I said, dot product only gives out the magnitude in a scalar quantity, not a vector. So if we will multiply 5i into 3i, it will just be 15 and not I squared, because scalar product gives out a scalar and I squared will be a vector. So we multiply these and we just add the other part, which is j. 4 into 2, 8, that's 8, and we get our answer as 23. So the work done will be 23 joules. So this was the basics of scalar product or dot product. Hope you guys got something to learn, and I suggest you do some questions on these because they are pretty confusing, and they're confusing, but they're very important. So hope you guys liked this video and you got something new to learn, and please give thumbs up if you liked this video and thumbs down if you didn't. And I hope I continue to give you guys something new to learn. And that's all. Thanks for watching. Please like and subscribe. Bye.